Welcome back, my dear students. Now we will do a small numerical to see how to do the or how to calculate the reduced level of a ground level using height of the instrument as well as rise and fall method. You could see the profile here. The leveling stuff used here is actually 4 meters high. So initially I have set up here at some point, and once I have done, the line of sight is perfectly horizontal. The RL of this point is known to you, that is 480.65, and here I will mark it as my benchmark. This is my benchmark whose RL is known to you as 480.65. So first I will keep my stuff over here, which I will get my reading as my first reading as my backside reading. I will denote as backside reading. Now I will keep my leveling stuff at A, B, C, D, E, and I'll get my all the readings as my intermediate side reading, that is IS. This is my intermediate side reading. This is my intermediate side reading. This is also my intermediate side reading. But if you see here, see the side reading at E I got is 3.930. Now if I place my leveling stuff at F, you could see the line of sight will be above the height of this leveling stuff, which means I cannot do the leveling work. I cannot find the RL of this particular point F while keeping my station point at here or the instrument at here, which means I need to shift the instrument. So what I do is the last reading taken from this point, say this is S1, I can take this as my foresight reading. Now what I do is I'll take all the W level, all the instruments, and I'll set it at another point such that this last point taken is visible to me, as well as the next points to be taken is also visible to me. So once I change this with respect to the mean sea level, the height of my instrument previously was this one. The height of the instrument was this one. When I change my position to S2, now the height of the instrument now has changed to some other new value. So I need to determine the height of the instrument. So what I do is, from the previous station itself I had found the elevation or the reduced level at E, which means now the reduced level of E is known to you. It is the similar case that of your benchmark. Now the reduced level of E is known to you. If you take the reading as your backside reading, that is the first reading taken from your new station point is always called as the backside reading. I could get, or I could establish the height of the instrument again. So in common you could see, when I have changed the point, I have taken a reading to my previous taken last point, and that reading is called as your backside reading. Or the point E, I could call it as the change point, because in the change point I have taken the foresight reading to get the reduced level, and I have taken the backside reading to get the height of the new height of the instrument. So again you will start doing the leveling. You will find the level of F, G, H, I. Again the height of the stuff is not convenient, so again I will shift the instrument to some other point, say this is S3. Then we will do the survey again, and you could see all the readings. So I could mark this reading as this is my intermediate side reading, this is my intermediate side reading, this is my intermediate side reading, and this is my foresight reading. Again there is another backside, intermediate side, intermediate side, intermediate side, intermediate side, and the last reading taken from the survey point is your foresight reading, where I stop my surveying work. So based on this understanding, we are going to tabulate this for both height of the instrument as well as the rise and fall method. I have a table containing these column attributes, that is instrument at, station, backside, intermediate side, foresight, height of the instrument, reduced level, and remark. So the instrument I am keeping at S1. The reduced level of the benchmark is known to me, that is 480.65. So I will write here, that is this one is 480.65, and the backside reading to that point is taken, I will get it as 0.450. So this reading is 0.450 meters. All the readings are in meters. Now I have at A the intermediate side reading. You could see here at A you have the intermediate side reading as 1.860. So I will mark all these points now. This is 1.860. So I have marked up to the point D, where my intermediate side reading is 3.675. Now, as I have told before, I need to have a change of point here at E, so which means this is the foresight reading. So I will mark here as my foresight reading, that is 3.930. and at the same point I have a backside reading also, that is 0.885. Now the remaining intermediate side reading I will add. So now I have added all the points which I had done the survey, and we have marked it in your field book. Here at E I have another station point S1, and from S2 I have viewed all this. Similarly at I have S2 and S3. So now I need to find the height of the instrument at the first case. As I have discussed, you could see here the height of the instrument at this S1 point will be reduced level of RL, that is the reduced level of benchmark, plus this reading, that is backside reading. That is, I can write here height of the instrument is nothing but reduced level plus the backside reading, that is 481. Now the reduced level of this A point will be, as you can see here, the reduced level of A point will be height of the instrument minus this intermediate side reading. That is, I can write this one as this is height of the instrument minus this intermediate side reading. Similarly, the reduced level of point B is equal to height of the instrument, which is same there, minus the intermediate side reading. Similarly, I'll get the reduced level of all the other points, that is height of the instrument at C minus the intermediate side reading. Reduced level of E is equal to the height of the instrument minus the foresight reading. Now as you could see here at E, now I am going to change the instrument to S2. As you could see, I have changed to S2. The height of the instrument now has changed, and the new height of the instrument is RL of E plus the backside reading at here, at this point. That is, RL of E is known to you, plus the backside reading, as you can see, is the new height of the instrument. So this process is repeated until we finish the survey, and I will mark all these readings over here. I get all the reduced point. Now if we do the check, sum of backside reading minus sum of foresight reading, that is, I can say here, this is the sum of my backside reading, this is the sum of my backside reading, and this is the sum of my foresight reading. Sum of my foresight reading should be the last RL. The last RL is this one minus the first RL. So if I see the difference between these two, that will be, so if you see here, sigma BS is this one and sigma FS is this one. So the difference between these two, I can write it as sigma BS minus sigma FS, which I get it as minus 5.7, and last RL minus first RL also I got it as minus 5.7, which means the check is also satisfied. This is the case of height of the instrument method. Now we will discuss on the rise and fall method, where the data entry is same as that of your height of the instrument method. Only the change happens for the rest three columns: backside reading, intermediate side reading, and foresight. Only the change is you have another column is rise and fall, and you have the reduced level column and your remark column. So here, as you have seen in the previous video, you can see the rise or fall is the previous reading minus the current reading, and RL of any point is nothing but RL of the previous point plus or minus the rise or fall. If it is rise, it is positive, and if it is fall, it is negative. That is why what I have written here. So just need to find the rise and fall, that is the previous reading minus current reading. You have the benchmark whose RL is known to you, that is 480.65. For standard A, I have the previous reading from the station point S, the backside reading, and the current reading as my intermediate side reading. So this is the rise or fall. If I see, that is the previous reading minus the current reading, that is a fall. Again at B, I have the previous reading as to A and the current reading at B, that is this one minus this one. Again a fall. Yes, I can calculate accordingly for the other cases. And when you come to the change point, you have the previous reading as your backside reading and the current reading as your intermediate side reading. So again you have a fall here, then So I have entered all the details here, either it is a rise or a fall. Now RL of this point is nothing but, RL of A is nothing but what? Your reduced level of the known points plus the rise of 4, which will get it like this. Similarly, RL of B is reduced for the level of the previous point plus rise of 4. You have RL of C, similarly reduced level of this point plus the rise of 4. Similarly, you will get all the values corresponding to up to the reduced level of n, doing the same thing, that is reduced level of the previous point plus reduce the rise and fall, rise or fall. I hope you understood this. Now you have the check for the same, this rise and fall method, that is sigma rise minus sigma fall, that is nothing but the sum of all these. So if I take the sum of all these, sigma rise minus sigma fall, either you can write this in separate column as sigma rise and sigma fall, or you could write in a single column, is equal to last RL, that is 474.95 minus the first RL, that is 480. You get the same. So your check is also done for this case. So for the check for this is also done. I hope you understood this.